Hello, in this video we are going to describe or discuss the conditions for rotational equilibrium. We already know we have two types of equilibrium. We have the translational equilibrium, which we discussed in unit 2. In that case, we had the net force to be equal to 0, acceleration was 0, and v was constant. Now we are going to have another form of equilibrium for rotation, which we call it the rotational equilibrium. That's going to be similar to translational, but for rotation. In that case, instead of force, we'll have the net torque to be 0. And if you remember that the torque is R times F, so it means that the force can be 0, or it can be the angle can be 0. Also, alpha is going to be 0 and omega is going to be constant. So that's going to be our rotational equilibrium. Now what you got to know is that sometimes we may have an object that's at rotational equilibrium but not translational equilibrium, and vice versa. So an object can be accelerating linearly but its rotation can be constant. And we have what we call it the total equilibrium. In that case, both the net force is 0 and the torque is going to be, net torque will be 0. Okay, so that's for an important one when they tell us the total equilibrium. Now, what's that going to be? That's another form of Newton's first law. And where we can use that, we can use it if you have a fulcrum or a pivot, and I can have multiple forces acting on it. So let's say here I have F1, and here I have L1, here I have F2, and we have L2. In order to find like those for equilibrium, most like we use those for hydraulics, for lifting and such things. What we can do is the torque net is equal to 0, and it means like torque 1 plus torque 2 will be equal to 0. Now what you notice that they are going to, one rotates it this way and this rotates it that way. That would be torque 1, that will be torque 2. So they are in opposite direction. We can calculate it. L1 or L1 F1 plus L2 F2 is equal to 0. So they are going, from that you can find whether we want to find L1, F1, L2, or F2. As long as we start with always net torque to be 0. That's it for 5.5, which is the net torque is always going to be 0 at rotational equilibrium.